أسعد الله صباحكم بكل خير. أسعد الله صباحكم بكل خير. أموركم طيبة إن شاء الله. Okay, it's 10 o'clock now. I need to we need to start. Okay, we have how many? Okay, my voice is clear to you? Clear. Okay.
Yes, clear, doctor.
Thank you. Okay, the last time we discussed the ABCD parameters and the importance of ABCD parameters. We also discussed example 5.1 in your textbook. Given, so what we need to focus on the ABCD parameters is Y and Z. So this is the impedance and the admittance. Once we have these, then the problem becomes easy. It's just these are just chapter 2, for example, given the power and power factor, etc. Okay, find the ABCD parameters. How we find ABCD parameters simply is by Z and Y. So the impedance of the transmission line and the admittance. Remember now, we multiply the impedance by the length of the transmission line. Okay, so the length here is 200 kilometers. Then we get the total impedance of the transmission line and the total admittance. Okay, so the impedance will have real part, imaginary part, and here could have G also, the conductance, but in this case here Y would be only imaginary part, susceptance, which is B. Remember now Y equals G plus JB. G is the conductance and B is the susceptance. And conductance plus susceptance, complex as a complex number, will give you the admittance. The resistance plus the reactance give you the impedance, or the series impedance. We call this the shunt admittance. So simply when we have Z and Y, then we just plug in these values in here, we calculate them, and as I told you, please to practice how to deal with complex numbers in by using your calculator. Okay, so please practice using complex numbers. Just to plug in these, and then VR and IR, you need to find these. Okay, so you just find ABCD parameters, which are these. A equals D, etc. So we already discussed this. This is per unit. The A, remember now, A and D is in per unit, not in ohm. Okay, because Y times Z, they cancel. 1 over ohm times ohm cancel. So therefore you get per unit. And this is in Siemens. Siemens because of this Y here. Y is in Siemens. Okay, so we already discussed, and then you will find ABCD parameters. After you find ABCD parameters, this now becomes just chapter 2. Again, to find the receiving end voltage, the receiving end current comes from the power over the voltage, power factor. This 0.95, as we explained in the last lecture, this 0.95 because the load was operating at 95% of its rated load. So this is the rated load, 9.5%. Square root of 3 We are multiplying. This is a three-phase. So square root of 3 times V line to line give you the phase current. Okay, so this is 1.26 kilo ampere, the phase current. So this is because this is per phase. Then we can calculate. This is what we want. We want, for example, VS. Very simple. VS, we just simply here, we use ABCD. See now the importance of using ABCD. We can determine the sending end voltage. And then we sending end voltage in line to neutral. So line to neutral, sending end voltage, and this becomes 345.8. 3.45.8 over, if we want to in per unit, 3.548 over what is given. So the given is what? Given is 345. 345 without 0.8. So it will give you almost 1 per unit in this case here. Maybe 0.999. Okay, but it's 345. 345 okay, over 345. 345 line to line. Okay. And because this is line to line, so you divide line to line over line to line, that will be okay. Or line to neutral over line to neutral to give you the same per unit. And why we need to convert it into phase angle? Because we want to find the current IS. So don't forget to convert it into line to line to neutral, VS. This is line to line. Okay, so don't forget to convert this into line to neutral, like this one here. Okay, line to neutral. So because we will use, why we need to line to neutral, because we want to find IS, the sending end voltage. So IS will be the line to neutral voltage here times 8.227 times 10 to the power minus 4 and an angle of 90 degrees. So this is IS. IS simply is here, which is what? Which is C times VR plus D. Can maybe change the color here, plus D times IR. Again, R is the receiving end. Okay, then you will get IS 1.241. Compare this IS with IR 1.246 IR 1.246 R, while IS is 1.241. But the angle is different. Why? Because we have shunt admittance. If we have just a short transmission line, so there is no shunt admittance, then IS equals IR. But because we have Y, the shunt admittance, then the sending end will be different than the receiving end. And then at the real power, whatever this is, the real power delivered to the sending end voltage, just simply V times I, square root of 3, because this is three phase now. Three phase means that square root of 3 times V line to line times I line times the power factor. Or 3, not square root of 3, 3, this one here, times 3 times V line to neutral times the current times the power factor. 3 because three phase. So it's okay. So please don't be confused with where we use the square root of 3. The square root of 3 is multiplied to line to line if we want to find the three phase. 3, not square root of 3, times the V line to neutral, if we want also three phase. Okay, to find the total three phase. So the sending end sends what? 730.5 megawatt. So we can now determine, you see, using the ABCD parameters, we can determine the power in the sending end. 730.5 megawatt, and the receiving power was given in the problem to be 730. So there's a loss of 0.5 megawatt. Okay, we discussed all these. And this is just simply, that's what you will do to find the no load voltage. No load simply is Vs over A. Now it comes now with the importance again of ABCD. We just divide by A, will give you what is the voltage at no load. So we want to know the no load. Why we want to know the no load? Because in power systems, we don't want the voltage to vary that much. So we want at no load, what will be the voltage at the load, or maybe heavy load, what will be the voltage? So we do it by the percent voltage regulation, or percent voltage regulation. This VR means voltage regulation. Okay, so at no load minus full load over the full load. Okay, so the no load is higher than the full load. So this will give you about 8.7%. This is too much. So this is too much. Okay, and then what we want to find, from the table A4 approximate current amount. We want also to find whether we are on the safe side or not. So what we need to compare, if we want to measure we are on the safe side, how far we are from the limit of the transmission line. The limit of what? Of the current, because every transmission line will carry a maximum current. You cannot exceed the maximum current. Therefore, we are rating at what? At 1.8 kilo ampere. This is the maximum current. Maximum current for what? For this conductor. From where we find it? From table A4. We go to table A4, and then you will find the current carrying capacity, the limit of this conductor. As we already explained how to use table A4. And why we multiplied by 2 here? Because we have two conductors, bundle conductors, two conductors. Okay, as given on the problem statement. So therefore, the current capacity will be 0.98, 1.8 kilo ampere. You see, now we deal with kilo ampere. Transmission line always on thousands of ampere, 5,000, 4,000 ampere. The full load line loss, of course, line loss means the sending end minus the receiving end. So this will be 30, that was 700. Okay, that was 700 given, not 730 as I mentioned earlier. So this is 30.5 megawatt. 30.5 megawatt. So this is given now, given at the problem statement, and this is what you found. Just get the difference, and 30.5 megawatt, and the full load transmission line efficiency. Now you want the efficiency, you just simply PR, which is the receiving end over the sending end. Then you get 95.8 efficient. You see, so from the ABCD parameters, so many things that as an engineer you can study, and you will be aware of what you're designing when you design a system. You need to get all these informations when you design the transmission lines. Of course, we design transmission lines for the future. Future means that what we plan to do in the future. So you get the information from the statistics, الإحصاء, and the plan, the government plan, what they plan. So you need to be in touch, of course, with what is going on. There will be a factory there, will there be shopping centers there, will be houses there. Then you can determine, then you can plan and study what all these parameters that you need to take care of. Okay, before you install any transmission lines of the system. Now we call it also the transmission line differential equation. We want to do this when we go to long transmission lines. Remember now when we say long transmission lines, that means this is exact. Okay, exact, okay. Exact values we get. So we make it as a long transmission line, if you want exact. Or instead of short transmission line, we make it medium transmission line. That's what we just discussed in 5.1. Medium transmission lines, which will be more accurate than short transmission line, talking about the same system. Okay. Same system. How you model the system as a short transmission line means that you are maybe 2% or so of your transmission line, of your data. You want more accuracy, then you go to do medium transmission lines. Just discussed 5.1. Even more accuracy, you go with long transmission lines. So you need to find A, B, C, D for a long transmission lines. But does it worth it sometimes if the line is short? Short means maybe 25 or 30 kilometer or 20 kilometer, for example. It doesn't worth that I model it as a long transmission line. So it will be perfect to model it as a medium or short transmission lines. Okay, the short transmission line will give us also a rough estimate. All right, so what we would like to also, again, now the Y and Z, you just multiply by the length, because these are given in ohm and the Siemens per meter. And what we have is this called the propagation constant. If we multiply Z and Y, it doesn't matter whether you put L and okay. So this is called per meter. So the transmission line is per meter. Okay. The propagation constant units are per meter. Okay, this is called the characteristic impedance, simply Z over Y, characteristic impedance. So if we multiply them, we get the propagation constant. If we divide them, we get the characteristic impedance. And you're already familiar with characteristic impedance. We use characteristic impedance to determine the maximum power that we want to transmit. So if the characteristic impedance equals the impedance of the transmission line, then the maximum power that can be delivered. Okay, so this is called characteristic impedance. So this is ohm. This is ohm. All right. So propagation constant and ohm. Why we are preparing you for these? Because we will use it for a long transmission line. Now we want to know to do more accuracy. on the calculation. So this is simply if it's transmission line, these are the values of A, B, C, D. You see now the difference? This is 1, this is Z. Here is 1 because here, why this is 1? Because we assume that the current in the sending end equals the receiving end current, the same current, same value of current, because no branches. All right. Medium transmission line, we call it pi circuit. These are from 25 to 250 kilometers. Okay, so in the problem statement, you need to look at the length. Can I use a medium transmission line? Can I use the long transmission line equations to solve a medium transmission line? Yes. It will give you more accuracy. But does it worth it or not? It depends on the length. But it will give you more accuracy. It will give you, if I use a medium transmission line, 250 kilometer or say for example 200 kilometer transmission line, and I solve it by the long transmission line equations. These are the equations now: sine, cosine, hyperbolic, sine, hyperbolic. It becomes a little bit complicated in terms of the equations. It's lengthy, actually. It takes time. Okay, it will give you maybe 2% accuracy, more accuracy. Okay, so that's it. Is this worth it or not? Then you decide as an engineer whether you want more accurate. Okay. So we are not just sticking that it is maybe 250 kilometers, then I will use medium transmission line. Sometimes we need to do long transmission line to be exact. And this is we called the pi circuit. Okay. So we call it equivalent pi circuit. Here we call it nominal pi circuit. The difference between these, there are both pi circuit. They're both looks pi. Okay. The transmission line like this, and then we have it like this. Okay, so this is impedance. Here is Z, and here is Y over 2. And similar for this one, Y over 2. Okay, similar for this one, Y. So this we call it pi circuit. If it is a nominal pi circuit, so this is the normal pi circuit, which is just simply Y over Z. If it is equivalent pi circuit, then we need to change this into a factor. We need to correct the Z. We need to correct the Z, so we call it Z prime. And the Y also, Y over 2. So we call it Y over 2 prime. And here we are. So we call it this one here. Z prime and Y prime. So there is a correction factor, we need to include them. Why? Because we want more accuracy now, and it's a long transmission line. So we don't want our calculation to be way off the value, the expected value. So we use equivalent, we call it equivalent pi circuit, not the nominal pi circuit. But both are pi circuit. All right, so how do we find these F1 and F2? So you want to focus now how to find Y prime and Z prime given Y and Z. So you already know Y and Z of the transmission line. So we just include the factors. Okay, we call it correcting or correction factors. Okay. Correction factors. Now, how to find these? Let me change this one here. We use a cosine hyperbolic of gamma or gamma L. gamma, again, this is the propagation constant times the length. This is per meter. Propagation constant is per meter. So we multiply by what is the length of this. So therefore, becomes a unit per unit now. This is per unit, dimensionless. Becomes dimensionless. And this equals this one here. So this gives you A. A is this cosine hyperbolic is this one. B is this one. B simply is Z prime. So we want to find Z prime, not Z. We want to multiply Z by the correction factor. Now remember now the difference between long line and short line. If in the assignment, I will give you an assignment on this. If you use a transmission line, I will ask you to solve by long line. Then if you solve it by medium line, although the difference may not be that significant, maybe 2%, but you will get 0. Okay, because we want you to use the cosine hyperbolic, the sine hyperbolic, or the correction factor, the Z prime. That's it. So you will not tell me that, okay, maybe I am only way off 2 or 3%, which is negligence. We don't work like this. Okay, if you increase the length, of course, the difference will be even worse. The difference between medium line and long line. All right, so this is B, and then C is simply this one. Y prime. So the idea here is now to focus what we want. We want to find Z prime and Y prime. And then we just use these equations to find the A, B, C, D. All right. All right, now sine hyperbolic is simply, as you can see here. So we can use these equations. We following quantities. So because now it will be hard maybe for some of you to find cosine hyperbolic or sine hyperbolic for a complex number. For a complex number. Okay. So what you will do, you will make it like this is cosine hyperbolic for a complex number. Therefore, you can do cosine hyperbolic for the real part. You do it by calculator. Real part times the cosine, that's the cosine hyperbolic of the imaginary part, which is beta. So this is alpha plus beta. Alpha plus j beta. Okay, so this will be a number and this will be a number. So you just plug in these numbers. The real part number and the imaginary part number. And the j, you will plug it in here. Okay, as you can see. So therefore, the complex part of the cosine hyperbolic, we will plug it here. So you better use these. Okay, cosine hyperbolic, how to use it. Okay, this is again sine hyperbolic of a complex number, a real part plus imaginary part. We want to find the sine hyperbolic of these. This is what, okay, so to be the same thing here. Sine hyperbolic times cosine, the imaginary part, plus j cosine hyperbolic, the real part, and the imaginary part. Remember now, L is the length of the transmission line. Okay, any question here? Zaid Samir? Zaid Samir is here or not here? Not here. Yusuf Sheikh? Not here. Osama Atiq? Osama Atiq? Okay, thank you. All right. Saad al-Naimi is here. Nabil bin Ammar, are you here? Omar Tarq, are you here? Omar?
موجود يا دكتور.
Okay. All right. Okay, so then maybe you will ask what about the rest? The rest will be there. All right. So we don't have a condensed question. Okay. So those students who do not attend, and then they will, and then they want to score a good grade. I want to make this clear now for you, because now what you see, what I can see, you will not get any credits. You will not get any credits even if you fail, even if there is 1 mark left for you. Okay, 1 mark left for you, you need to take it. So you get maybe 58 or 59, and we did all our best, so you will not pass the course. Very simple. I want to make this straight for you. Okay, so you need to, these are all what you can see here now is just focus. So you cannot just come in class and then you will ask me very, very simple questions that you did not read. So you think that all the information will be on your cheat sheet, and you are not attending the class. By the way, okay, so we will see you, inshallah. And the exam will be just simple exam as the midterm, but it is your job to pass the course. Okay, so please don't expect any help. I need to finish. Okay, so please don't. I need to finish. Yes, I need to finish. Okay, so please don't expect that you will get more. You will get credits that just because you are losing whatever, that you will be or you will fail maybe, or you want maybe to whatever, to take maybe other courses because other courses depend on this course here, etc. Anyhow, this is up to you what to do. You are mature enough. I don't want to tell you what to do. All right, تفضل يا عبد العزيز.
بس عفوا دكتور، انا سمعتك تنادي اسماء الشباب بس ما ناديت اسمي، ما سمعت.
نعم، اذا ما سمعت معناها who's talking now? عبد العزيز.
عبد العزيز الابراهيم. نعم.
لا I did not ask you. Okay. Not all. All right, I did not ask your name yet. Okay, so this is clear, inshallah, for you. Okay, so if you do not attend, it means that you. Yes, تفضل يا تميم. تميم, you are raising his hand. تفضل يا تميم.
لا تفضل دكتور. بس دكتور inform me that يعني معظم الشباب ما دخلوا لأن كان عندنا الترم، ففي شباب راجعين البيت فكذا ما قدروا يحضروا يعني.
Okay. All right. Okay. And the last time also they did not attend, so they are preparing for the midterm, correct? The last lecture also, those who I asked them to attend, they did not also attend. Okay, because they are preparing for the midterm. Yeah, they are preparing for this. Okay. All right. And what about you? You attended the midterm? You had the midterm also with them?
Yes, Doctor.
So what?
Yes, Doctor, I attended and I came back. I joined from a laptop.
Your mobile? Or from your mobile. So you can join from your mobile. You can stay on campus there to attend the lecture, and then you can leave. You see, this is what you should do anyhow. If they can listen to the class, that will be good. They can listen to the class, maybe for the listen to the recordings of the class. That will be good. Okay, we will have inshallah a quiz on this is today's quiz on Sunday on these. Yeah, I will announce it. We will have a quiz on Sunday on these. So inshallah, by Sunday you should have finished your midterms, correct? By Sunday, you should have finished your midterm.
Doctor, no, on Sunday you will not have finished everything. Can you make it at least on Tuesday or after the vacation?
And then we will not have time. Then you will not do good. The quiz, okay. Well, I will see, because this is part of it. This is running actually. We cannot just wait until everyone finished and then we will give you a quiz. So you will have an assignment. You will have a quiz. This is a course that runs like other courses. We cannot wait because you have only 2 quizzes, I guess we give, or 1 quiz. Or an assignment. So I will see whether I will give an assignment or a quiz. Okay, so maybe okay. So I need to see, but we have to run the course, and we cannot just wait for others to go. Otherwise, you will not do good in the assignments and quizzes. It will be only very few. So we need to give you more quizzes that you can. I can take 1 quiz maybe out. But if you do not do more quizzes, then we cannot delete any quiz. All right, so we can, I will see now. All right, there, what we will do here for this transmission line differential equation, A, and now we have this A1 and A2. These are parameters now. Why we are doing this now? We want to have a correction. Now we want to correct the Z to make it Z prime, and now the VR here, for example, VR, we call A1 and A2. You want to find the voltage at the receiving end, A1 and VR. So how to find A1 and A2? These are the equations. Okay. So A1 will be VR plus Z over 2. So IR is this, A1 minus A2. So we want to find A1 and A2. This is the idea here. We want to find A1 and A2. Okay, we'll come to this in a moment. Now we can do this as differential equation as explained in your textbook, but at the end we will have A of x. X means that the length. So we start from 0 at the receiving end until L at the sending end. Now we go backward. Okay, so measuring the lines from the receiving end. Okay, not from the sending end, from the receiving end. X will be 0, and then all the way to the sending end. Okay, so this will be again, this is just what is given here that we explain. Now how to find it. Now to find A, B, C, D for a long transmission line. Okay, just focus now what we do. These are the equations. So we will have these equations now. You will have these equations, okay, in the cheat sheet or formula sheet. And then what you want to find cosine hyperbolic of this. So you need a calculator that solves cosine hyperbolic. Okay, and sine hyperbolic. And to find these, actually you can make them in this using these values here. Okay, so make it easy for you. Cosine hyperbolic lambda, because this here sine hyperbolic will have a real, will have this one like this. So this will have a real part and the imaginary part. Cosine hyperbolic will have real part and the imaginary part. This one have real part and imaginary part. Gamma. The propagation constant will have real part of the transmission line. Real part, imaginary part. This is a complex number. If your calculator do this, that will be okay. But most of the calculators that you probably deal with will not have this. So try to, if your calculator do a complex number, cosine hyperbolic, and give you the real part and the imaginary part. give you like this, that will be okay. If not, then you need to do these. Cosine hyperbolic, cosine, blah, blah. So these are just numbers. Now, alpha is the real part of the gamma. Beta is the imaginary part of gamma, of this gamma. All right. Yes, Muhammad Murtaza.
Yes, doctor. Regarding the x in the previous slide, we calculated from the receiving end, right?
Yes.
So it will be from receiving end, I will go backwards. 5
Yes.
meters from receiving end, 10 meters. Okay. Thank you.
Okay. All right, then, okay, so let us do this example here. You see now these examples are straightforward. You just focus on what equation I will use, and also focus on the complex numbers. So the first part here, which is given here, blah, blah, 300 kilometers. From here, 300 kilometers, so it's above 250. So therefore, you need to solve it by as a long transmission line. Okay. And then what's given these the Z and Y for the transmission line per kilometer. We always have the per kilometer or per meter, or because these are the one that you will get actually the transmission line is given per kilometer. Then your system is how many kilometers. So we want to differentiate. So we make it small y and small z. Then you get the characteristic impedance. Okay. And propagation constant. You just multiply z and y. Okay, so that's it. So then you will find the z impedance, and this characteristic impedance is a complex number. The gamma also is a complex number. The difference here, the units of the characteristic impedance is in ohm, not ohm per meter, because you already multiplied by the length. And this is per unit. Okay, this is per unit. Complex number in per unit. Gamma. So therefore, we have the characteristic impedance and the propagation constant. Your formula, we already discussed this, how to find the formula. Okay, given cosine hyperbolic, sine hyperbolic. So we'll just plug in the numbers here. And then you will get sine hyperbolic is this part here. Cosine. After you get the sine, then you will have the A and D. Sine hyperbolic, cosine hyperbolic. Then you will just get the A, D. The A and D is this cosine hyperbolic, which is this one. Okay, this one. A and D. A equals D. B is simply this part here, sine hyperbolic, times 266.1143. So this is it. So we just make the equations here like this one. 266.14Z characteristic. So simply we find A, B, C, D according to the equations that's already given. After we find A, B, C, D parameters, okay, so this is we call it the nominal pi circuit. Now this is the nominal pi circuit. The B parameter for the nominal pi circuit is this one here, so Z. So this is nominal pi circuit is 99.4. If it's nominal pi circuit. 2% larger than the exact value. Remember now, what we do, this cosine hyperbolic, sine hyperbolic, is that we want the exact value. If we just make it Z, only Z, not Z prime, then we call it nominal pi circuit. Okay, so this is Z prime here, as we mentioned that how you find A, B, C, D parameters. So these are the how to find the A, B, C, D parameters, and how you calculate Z prime. This is the way we calculate Z prime. Remember now, it's the same circuit, same circuit, but we call this Z prime Y prime over 2 because it's a long transmission line. So we need a correction factor. A correction factor of what? Of Z times the correction factor. This correction factor here, we can calculate it at this sine hyperbolic, this part. So the idea here to find Z prime, Y prime, we want to construct this circuit here. And then we can find A, B, C, D. That's the idea. So you want to construct this first thing, you want to construct the circuit. So how to construct the circuit? So this is Z. Either we do it this way or we do it this way. Z is given. Z small times the length, give you the impedance. And then sine hyperbolic over gamma L. So we already know how to find these. So that will be Z prime. Y prime over 2. Why we have over 2? Because Y prime will split Y prime on one side and the other side. These ones. So you get Y prime over 2, Y prime over 2. One side, one side. Okay. Then Y prime over 2 times the correction factor of F2. So F1 is a correction factor of the impedance. F2 is a correction factor of the admittance. And we can use these tan hyperbolic. You call sinh equals cosine, so or we call sine hyperbolic. Or tan hyperbolic. Okay. So we can calculate these simple now. After calculating Y prime, Z prime, then we plug them here to find A, B, C, D. The idea always we want to find A, B, C, D. What we want to do, later we will see what we do. Already shown how to find the sending end, the receiving end, etc. Okay, by using A, B, C, D. So focus on how to find A, B, C, D on the long transmission line or medium transmission line or the short transmission line. What becomes a little, okay? So therefore F1, we can calculate F1 here and F2. Okay, I need to go here. Muhammad Shaat is here. Muhammad Mahmoud Hassan is here or not here? Muhammad Shaat. Okay, Muhammad Mahmoud Hassan. Muhammad Ibrahim Fakhro. رد علينا بسرعة. محمد سامي.
Yes, doctor.
بسرعة ردوا علينا. محمد مرتضى. محمد طه.
Here, doctor.
يا محمد مرتضى. ومحمد طه. يا محمد مرتضى ومحمد طه.
I'm Muhammad Murtada.
طيب. محمد مرتضى. اوكي محمد محمود ماهر. محمد خالد. جاد. محمد هاني.
Here, doctor.
محمد الطيب. محمد فهد حريري. ليث. خليل خالد. حالتكم صعبة. حسام العارضة.
Yes, doctor. Here.
اوكي فهد غالب. انور هاشم.
Yes, doctor.
عامر حسام. عامر العواد. وأحمد شهاب شبيكة.
Yes, here.
وأحمد علي الرياحي. وآدم. أوكي. وآدم. عبد الله سالم الجابري.
نعم
ردوا علينا بسرعة يا آدم.
موجود
عبد الله. عبد العزيز دلول.
Yes, Doctor.
عبد العزيز اليهري. No. عبد العزيز الابراهيم اوريدي. عبد العزيز
إيه.
ابو هزاع. عبد العزيز هو. عبد العزيز هو. ابو هزاع ورا اليهري. عبد العزيز من عبد العزيز اليهري. اعطينا عبد العزيز ابو هزاع. not here. فهد. فهد يعني جاي متاخر يا فهد الله يهديك. سالفه جاي متاخر يا فهد لكن يلا. مين اللي بعد يقول لي اوكي خلاص اوكي so I need to stop recording now.